real plane for the polar form. We need to discuss the real plane for the polar coordinate system. There you go for the real plane of the polar coordinate system. We are at the center, we have origin, which is 0. This horizontal line is my cosine axis. This vertical line is my sine axis. Look, from the polar form we need to consider the angle in the coordinate system. We are taking angle in the polar form. Therefore, this horizontal light brown line is the cosine theta. It is the cosine axis, which means that it represents all the angles in cosine form. Similarly, this vertical blue line is called the sine theta. So we call it sine axis. It is a sine axis, which means that it represents all the angles along this vertical line in sine form. So this vertical line deals with the sine theta, this horizontal line deals with the cosine theta. That's why we call it cosine axis and sine axis. Look, when you compare the polar form with the Cartesian form of coordinate system, there's a big difference. For the Cartesian coordinate system in xy plane, this horizontal line is the x-axis. In xy plane, it is represented by x. This vertical line was the y-axis. It was represented by y. It was for the xy plane in Cartesian coordinate system. In complex plane of the Cartesian coordinate system, this horizontal line was the real axis. All the values along this horizontal line were in real forms. This vertical blue line was the imaginary axis in complex plane of the Cartesian coordinate system, which means that all the values along this vertical line was in imaginary form, having iota. But when it comes to the polar form, this horizontal line is represented by the cosine theta. This vertical line is represented by the sine theta. We have two fundamental quantities in trigonometry. One is sine theta and cos theta. These are the two basic fundamental quantities. Look, we are taking the real plane here, so we have nothing to do with the complex plane. Therefore, we have simply cos theta for the horizontal line and simply sine theta for the vertical line. We don't have iota here, so it is the polar real plane. This is the first quadrant. Here is the second quadrant. This is the third quadrant, and this is the fourth quadrant. This is the polar ordered pair for the first quadrant, polar ordered pair for the second quadrant, polar ordered pair for the third quadrant, polar ordered pair for the fourth quadrant. Look, both the elements of the polar ordered pair are positive in the first quadrant. The basic logic of the ordered pairs is absolutely the same what we have done in the Cartesian plane. In the Cartesian plane, both the quantities of the ordered pair are positive. The same thing happens here for the polar form. In Cartesian plane, we had x, y, are a and b iota, but this time we have r cos theta and r sin theta. Only the elements are different. The basic logic is the same. Similarly, in the polar ordered pair for the second quadrant, this quantity is in negative and this one is in positive. In the third quadrant, this quantity is negative. The second quantity is also in negative. So both of the quantities of the polar ordered pair in the third quadrant are negative. This is the polar ordered pair for the fourth quadrant, where the first quantity is positive, the second quantity is negative. Let me compare the ordered pair of the Cartesian plane and the polar plane. I just want to compare the ordered pair of the Cartesian coordinate system for the real plane and the ordered pair of the polar coordinate system for the real plane. XY is the ordered pair for the real plane, which was the XY plane for the Cartesian coordinate system. This is the ordered pair for the real plane of the polar coordinate system. In Cartesian coordinate system, the first quantity was x. Here in the polar form we have r cos theta. R cos theta. R is the radius of the circle from the center up to the border, because we are dealing with the angle. Similarly, in Cartesian coordinate system for the real xy plane, this was my y. The second quantity was my y. But here in the polar form for the real plane we have r sin theta. It is r sin theta. So for the x we have r cos theta, comma, for the y we have r sin theta. This is the difference between the real plane for the Cartesian coordinate system and the real plane for the polar coordinate system.